Frequency shift keying. FSK is a frequency modulation scheme which is used to transmit digital data. FSK modulation uses different frequencies to transmit different symbols. This is done to decode the symbols at the receiver end easily. So not only two frequencies are used. Depending upon the number of symbols we have to transmit, we choose the many carrier frequencies. In your case, two frequencies, we need two frequencies. For example, to transmit data 0 F1 frequency, data 1 F2 frequency. So at the receiver end, when it receives F1, it will decode as 0 and F2 as 1. FSK and FM are similar. FSK is used for digital data where there is discrete shifting from one frequency to another in accordance with the logic state being transmitted. In this case, basically two frequencies are used. FM is used for analog data and can have a continuous range of frequencies within limits. Output for a continuous analog signal also within limits. Usually the frequency range is limited as is the modulation signal. Key is the act of applying modulation. The term goes back to the days of telegraph and Morse code and refers to the pressing a mouse key. It can apply to something other than modulation. Applying DC to telegraph line, for example, FSK or frequency shift keying is the process used in slower modems up to 1200 bpms, where a carrier wave in audio band is switched between one frequency and another depending upon whether the data is 1 or 0. That is, the carrier wave is frequency modulated. In other throwback to Morse telegraphy, even today the bits in serial communications like RS-232 are not called 1 and 0 but mark and space. So a mark would make a mark on paper tape, as the receiver and space would not. Frequency of signal is relatively low, of the order of kilohertz for instance. The antenna for its reception and transmission, which must have dimensions of the order of the signal wavelength, becomes b too large in size to be physically realizable. So the carrier frequency used to enhance the realized frequency components of the signal in order to make the antenna dimension practicable. Frequency translation and multiplexing. When a number of signals occupy the same frequency band and we want to transmit them together, it is natural that overlap and hence distortion will occur in the frequency spectrum of each signal, which is undesirable. Hence, by using a carrier frequency, we translate each signal to distinct frequency band so that they can be transmitted together without any chances of overlap. To decrease the ratio between maximum and minimum signal frequencies, this is a variable for the purpose of designing a suitable antenna which can transmit and receive suitable for the extremes of the frequencies present in the signal. For instance, if the lowest frequency in a signal be 50 Hz and the highest be 20 Hz, the same antenna cannot be suitable to cater both components, as the frequency ratio between highest and lowest components becomes as large as 1:400. But if using a carrier frequency 50 Hz, we translate the frequency range into 50 plus 50,000 Hz to 20 plus 50 Hz or 70,000 Hz. For the same ratio becomes 1.4 and a single antenna can cater to both extremes of frequency. These are in short some of the fundamental frequencies of modulating high frequency carrier signal by the message signal of low frequency.